Hello, welcome. This is Algebra 2, Chapter 5 review. Here we have exercise 16, and we have a polynomial that we're meant to factor entirely. Now the first step in factoring, as we talked about in a prior chapter, is to factor out any common factor. It reduces the number, it makes life easier. I'll go back to this later. But first notice that there's a 2 that can be factored out of all of this. So I'm going to first rewrite the polynomial. And then factor out a common 2. So that means we have a 2 in front. 2x to the third minus x squared plus 6x minus 3. There we go. Because the numbers are reduced, and now that we have to start making some guesses, we have fewer guesses to make. Remember the rational root theorem, which says we're looking for fractions where the numerator are factors of the constant term, which is a 3 in this case, divided by factors of the leading coefficient. And then it's the positive and negative versions of all of these. So, for example, we have plus or minus 1 over 1. We have plus or minus 3 over 1. We have plus or minus 1 over 2, and we have plus or minus 3 over 2. We use the factors of the numerator on top, factors of the denominator on the bottom. Now, if you look back at the original polynomial, you'll see that it could have been worse. If we hadn't factored out that 2 to begin with, we would instead be worried about factors of 6 on top and factors of 4 on the bottom. Just a lot more numbers to check, a lot more unpleasantness. However, even as it is, we still have 8 different numbers to try. We have positive 1, negative 1, positive 3, negative 3, positive 1/2, negative 1/2. And that's it. And of course, I now see that I misspoke and I miswrote. The last number should be plus or minus 3 over 2. I apologize about that error. But what I was saying still holds true. It would be a lot worse if the numbers were 6 and 4. And now we have our list. I'm going to rewrite the list. There's no reason why you should have to rewrite the list yourself. But I just want to make sure we're crystal clear on what our options are. Right? We have 1 as a number that's worth checking. We have negative 1 as a number that's worth checking. We have 3. We have negative 3. We have 1/2. We have negative 1/2. We have 3/2, and we have negative 3/2. These are all the numbers that are worth checking according to the rational zero theorem. Now that we've actually got the numbers that we should try, we actually need to try them. It doesn't matter what order you try them in, but you've pretty much got to try them at least until you get one that works. So I'm going to stick 1 into my function and see what I get. In fact, I get 8. So I know that 1 is not a winning number. I'm going to go ahead and do that with the next number on my list, negative 1. If I stick negative 1 into the polynomial, I get negative 24. Now you can do this with direct substitution or synthetic substitution, but either way, you get negative 24, which means that negative 24 is not working out well for us. If I do it with 3, you'll see that you get 120, and that is simply not a successful experience either. So that means that 3 is not one of it. And it's getting tedious and perhaps slightly frustrating, but plug along with negative 3, you get negative 168. Yep, that's not working out either. Too bad. Now we're halfway through the list and we haven't found any. Keep going into the fractions, I suppose. Substitute in 1/2. And when you substitute in 1/2, you get 0. That is a good sign. Getting 0 means that 1/2 is a winning number. Now, you've got a couple choices here. You could continue on with the other numbers and hope that some of them work. And if they do, good for you. Or you could just go ahead and take your 1/2 and use it as the basis for synthetic division. That's what I'm going to do here. Because I know 1/2 works, I'm going to stick that into synthetic division with my polynomial. I'm going to use the reduced polynomial, the one I factored the 2 out of. So my coefficients are 2, -1, 6, -3. 2 goes down in front, multiplies by 1/2 to make 1, adds to make 0, multiplies by 1/2 to remain 0, adds with 6 to make 6, multiplies by 1/2 to make 3, and when you add you get 0. Now, we knew this 0 was coming because I had already got it with direct substitution, but I'm still pleased that it worked out the second time. It's a good check to have. Because of this, we now know there's that common 2 factor in front. There's an x minus 1/2 factor, and be careful about this, 2x squared plus 6 factor. Now that comes from the ending numbers from the synthetic division, and the 0 means there's no plain x term. Now the way we were taught with the book here is to keep writing it out. We got 2x minus 1/2, and then we can factor out a 2 from all the terms in the second piece, factor out a 2, and that makes x squared plus 3. The reason you want to do that is you want to take that 2 that you just factored out and distribute it back into the prior term. So it's 2x minus 1, x squared plus 3. Now, you might immediately recognize that the last bit, the quadratic, doesn't factor, or you might not. But either way, we should talk about how we would check. This is what I mean. We have this part, the 2 and the 2x minus 1, fully factored, looking beautiful. Over here we have the x squared plus 3, and we're just not yet sure if that's fully factored. So to check that, take your x squared plus 3. You could try to factor it just nicely in your head. You probably won't get very far. So then we're going to go ahead and use the quadratic formula, right? So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, of course, because it's x squared plus 3, b is 0, so it's 0. You can put a negative in front if you want. Plus or minus the square root, we got 0 squared, which is 0. We have minus 4 times 1, a is 1, c is 3, all over 2 times 1. And the reason why I'm highlighting this is because we have 0 plus or minus root negative 12 over 2. And when you're doing this to check your work on the factoring, because the discriminant, or the thing inside the square root, is negative, that means no real zeros. And that in turn means no more factoring. So that's when we return triumphantly and confidently to the prior answer, 2 times 2x minus 1 times x squared plus 3, which I just drew in a purple box. It's a bit of work here. Some of it's luck in terms of checking the correct numbers. some of it's insight, but you should be able to plug through either way. And then finally, if you do have a graphing calculator, you really should be talking to me about how to quickly be testing the direct substitution when you're trying those numbers at the beginning. I just want to help save you some time. But thank you for watching.